Welcome everybody. Glad to see you. Um, Today's episode of Tech Talk Tuesday is kind of about some of the little creations and funky stuff that I play around with. It's not 100% my role as a training manager, but it kind of takes that into place, right? So as training manager, I need to be able to understand concept and be able to pass them on to other people. But the other part of it that I really like about that is I want to figure out things. I've had people ask me questions. Well, what would happen if you did this? I'm like, I don't know what would happen. Let's find out, and I'm going to find out. Or things that I realize that I kind of have a surface understanding and I don't have a deep understanding. So maybe I only need to transfer a high level understanding. I don't need to drill all the way down, but I need to drill down so I understand some of the things in the background. So that's kind of some of the things that I wanted to share with you today. Some of the things that I've done, um, and also because I'm a nerd, right? I love playing around and making things and creating things and coming up with weird ways of solving problems. So let me show you. I'm going to switch to my overhead camera, and let me show you one of the things that I've been playing around with. So one of the things that I've been playing with is event bicoders. And if you don't know event bicoders, event bicoders take a switch, anybody's switch, and just tells the two-wire system that the switch has changed. So here I've got a event bicoder. This is a serial number PR00712. And you can see it's an event bicoder down here on the bottom. So this side will connect onto the two-wire path. And what's kind of cool is it will connect anywhere into the two-wire path. It doesn't have to be at the device I want to manage, anywhere along that two-wire path. This side is intended to connect to the device or the switch input. So any switch that's going to give me some input, this would connect onto it. So in some of my training classes, I've shown people how to take a dumb rain switch, right? And rain switches are great, but they are kind of dumb because they just turn it off and on based off of what those little cork discs do. So they swell up, and then they open the switch or close the switch, and you're 100% at the mercy of the switch and when it's going to open. Now we won't get into the durability because I know contractors have issues with durabilities about different brands of switches. That's completely separate. But all I want to do is take this switch output, and instead of just letting this switch control my system, I want to influence how it controls my systems, not give it direct control. So what I'm going to do is connect this to the output, and now with this switch, I'm going to use this switch and say if this switch is open or closed, then we can tell the system to do something. So that's an event bicoder, and that's been around for a long time, and it's something we've known about. It's something I've known about. Wasn't a hard concept or a big reach for me. So with these two connected, I can now put in a start, stop, or a pause condition and say when this switch opens or closes, do something about it. Okay, so pretty well versed on that. Well, the other thing I was kind of thinking about was like, what other switches can be done with it? And since my background is all on the West Coast, so I do, West Coast of the U.S. I haven't done a whole lot of work in tanks and other bodies of water. Most of my water sources are domestic water sources, or maybe a rain catchment. That's about the extent of it. So I didn't understand how people use tanks and how they might use them. Like, well, so I've theoretically talked about how to level in a tank. Well, it's time to stop theoretically talking about it. Let's actually do something with it. So this is what I brought in with an event bicoder. So instead of using the rain switch, we'll get rid of that one. I brought in a tank leveling switch. And so here's a tank leveling switch. And I've seen these before as a contractor, and you might see this style in a sump pump. Okay, and this is very traditional of a sump pump. This was made to plug into the wall, and then your pump would plug into this one. And whatever this switch would do, it would influence your pump. So this was, if we listen, there's a ball inside here, and as this changes positions, it would move from up or down. It would open or close the switch. Okay, so again, I don't want to be at the mercy of this switch. And maybe I don't even want to use this. Maybe I just want to cut this off and use this straight as a switch. So I ordered one of these. This is one of the things I also like about my job is I got a company credit card and I want to know about these. So I ordered these and I got them and they're great. Now I'm going to learn about them. So this switch could be normally open or could be normally closed. So the switch contacts could be open, they could be closed. Really doesn't matter because I have the ability when I go into the programming of the event bytecoder to change that one. So what I'm going to do is take this switch and connect it to the event bytecoder. And I'm going to say when the tank level goes up, the ball is going to change position and it's going to open or close. Let's see if we can hear that one. Open or close the switch. I really don't care if it's open or closed, but now I could use this one. What's kind of nice about this particular style of float switch is I've got lots of room on it, right? And there are ways to tether this, and there are kits in which you can tether it to this point and make sure that it only has so much room to wiggle back and forth. So these are available normally open, normally closed. They're available with this plug style. What I have found where I purchased mine, you can purchase them anywhere, but I found that Grainger has been a really good supply place for me. But lots of different places where you can buy these switches. You need to know your model number. So this is one type of a switch that I want to play around with tanks and connecting it to an event bytecoder. Now, once this is connected to an event bytecoder, I can say when the switch opens, start the pump, or when the switch closes, start the pump, or when the switch opens, I want you to pause my irrigation system. So all these different things I can do with the start, stop, or pause, which we've had for a while. We've talked about those, but now I can use someone else's switch, this switch, to influence those decisions. So this is one type of switch that I found. Kind of like the idea. Actually talked to one of our distributors in Texas, and he was talking about very similar to this style. I think the very similar style that he was using. I don't know if he was using that brand. So another one that I wanted to take a look at was, this is a style that may not work for people. Whereas this, what's kind of nice about this style is you can drop it in a tank and it can be all fed down from the top. Well, you may not be able to use this style. You may not be able to use a style like this one because you would need some sort of a bulkhead fitting to get through the tank or some sort of threaded connection. But this is just a 1/2-inch thread and there's a single switch on here, single output. What's kind of nice on this one is this can either be used to say when the tank or water level increases or when the tank or water level decreases. So in this case, we can see its natural position is to be down. And as the water level rises, let's move this up a little bit. As the water level rises, the switch contact will close. And there's actually I think there's a magnetic contact in here. So it's kind of nice on this one. As the tank level rises, I can now say, do a condition, start, stop, or pause a program. But if I flip it upside down, as the tank rises, it will open the contact. So I can just, by flipping the position of this switch, I can make it do different things. Again, I don't care if this switch is normally open or normally closed, because I can go into the bytecoder and the start, stop, pause conditions and say when the switch opens or switch closes, I can do things. So these are switches that I have not had experience with because I haven't dealt with tanks. So I went and bought these switches. They are not baseline products, but I'm going to integrate them with the baseline product. I'm going to integrate them with an event bytecoder. And just as a reminder, event bytecoders are intended to talk about a switch position. Is the switch open or closed? That's all it's doing. And because the other type of event bytecoder that I bring up in my trainings is a coach's button, right? Because a coach's button is very, very similar. It just has the button built in. And these are, all of these are intended to be a sensor that tells you, is a switch open or is a switch closed? That's all it's doing. It's a sensor. It's a sensor indication on someone else's switch. This one is a sensor indication that there's a person there pressing the button. That's all it is. That's all these do. So lots of different things that you can do with event bytecoders, but the concept on event bytecoders is what can we do with a switch? I haven't had the opportunity to play around with tanks, so I'm going to create my own tank setup. Okay, so that's one thing I've been working on. Actually, I haven't had an opportunity to play around with that yet. So the other one that I have played around with, that I played around with it last, probably earlier in the year, was I wanted to look at some tank leveling again, because I don't have that experience. I wanted to look at that one. Let me show you. I've already taken it down, so I will show you what I did in my back patio. So here on my back patio, I've got a soil moisture sensor set up. I wanted to look, my premise here was, what's the best way to indicate the water level in a tank? Is it a soil moisture sensor? So this is the 5315B, it's our longer soil moisture sensor. It's like, is that a good way to do it? Are there other pieces of hardware that might be better to do that one? So what I did on this one is I didn't have room for a 5,000 gallon tank on my back patio. Well, because I live in suburbia, so that wasn't, and nobody was going to reimburse me for spending that money. But I found that I could get 6-inch clear pipe and couple that together, and I was able to create. I think I was able to create a 7-foot column of water, and that simulates a 7-foot tank. And then I could drop a soil moisture sensor in there, and you can see my lines that I created to show the different level markers on there. And in the right-hand image, I'm at 1 foot of water, and I've got a soil moisture sensor. And so what happens when the water dries down, drops down to that level? Now I can start watering, or say that my pump's about to run dry, so stop watering. I can start different conditions. So I wanted to measure that one. So this was one version of that I did. So in my faux 7-foot tall tank, it was a 7-foot tall tank, it was just only 6 inches wide. What happens, how accurate is this? So that was using the large soil moisture sensor. So then I wanted to compare it against the other one, which my other premise was, is a pressure transducer better? So this is our BL5406 kit. And let's take a look at that one on the overhead camera real quick. We'll come back to that one. So on that one, what I did is I connected this guy into my column of water, and if the 5406 kit has a bicoder that connects into the 2-wire path, and this pressure transducer. And pressure transducers have been around in the industry, have been in the manufacturing industry for a while, haven't been much in irrigation, maybe only on your pump station. We took this and allow you to put it anywhere in your main line. Well, if you connect this to a column of water, each foot of water is about half a pound of pressure, 0.433 psi to be exact. And I measured that one. So I connected this in. So let's go back to the share screen. And I connected that in and wanted to see what happens when I am down to 1 foot of water. So you can see I have it connected in the 2-wire path with the bicoder, but in the right-hand image, I've got 1 foot of water. So that should be about 0.4 psi pressure, and that was pretty accurate. So I compared that. So I could drop the water level in my fake tank. So I was able to use that one. So that was one version. Now our bicoders measure from 0 to 150 psi. Well, is there a better way to do that? Is there something that's a little bit more accurate? So then I wanted to know, what would happen if I just took the 5406, just the bicoder itself, and then brought in someone else's pressure transducer? So what I did is I brought in an aftermarket lake level transducer, and we'll show you what that looks like in just a moment. So I dropped that in the column of water. Let's stop that and come back to my overhead. So we looked at, compared this guy against a lake level transducer. So here's the lake level transducer, and this is coiled up. And what was really, again, since I didn't have any experience dealing with these, I had to manufacture my own ways of dealing with them and coming up with them. So I knew how this worked. I knew that this was made by, this is particular one that Baseline uses is made by Dwyer Industries. We bought that and then created this so it could connect and communicate into the 2-wire system. This is rated from 0 to 150 psi. This lake level transducer comes with a 40-foot cord on there and a transducer that is rated from 0 to 5 psi. 0 to 5 psi, and you can buy different ones on this one. So I sought out. Turns out this one is also a Dwyer as well. So I bought this one, and my first impression was like, this is completely different. Wow, they're so different. And then I realized, again, playing with them in my laboratory, I realized, well, what does this little cap do? So I pulled off this cap, and then it occurred to me, these two are exactly the same. There's nothing magical about this. This is just a cap that keeps debris from getting into the pressure transducer. And honestly, it would fit on there. Well, the only difference is this is heavier. So it's going to go straight down, and it has a 40-foot cord on there. So it's intended to drop down into perhaps a 40-foot lake. So again, each foot of water has about half a psi of pressure. And we could use this to indicate it. So what in my experiment was, which is more accurate for measuring it? This reads 0 to 5 psi. This reads 0 to 150 psi. Which one is more accurate? Oh, so it's kind of, I'll cut to the chase on that one. Turns out this is slightly more accurate because this is a tighter range, but it didn't matter in foot of water. It really didn't make that big a difference. The biggest difference, the reason to use one over the other, is how you're going to mount it. Right? This is intended to thread into a fitting, and this one is intended to drop into a tank. So let's take another look at that on the diagram. Go back to share. So if we look at the picture that I have, you can see that I have the lake level transducer suspended from the top, whereas the pressure, the baseline pressure transducer is threaded into a fitting. So if you have a fitting that you can thread into, the 5406 kit is super convenient, but if you don't have, if that doesn't make sense, then maybe a lake level transducer and just the 5406, the BL5406 device only might make more sense. So that was kind of my takeaway on that one. The other thing I found that was the soil moisture sensor is great for a very narrow, very narrow range if you're going to measure water level. But if you are going to, once you're outside of that range, it's invisible. With any one of these pressure devices, I can see the pressure across the entire range, right? I can see when a tank is 50% full or way less. So here's one that's completely different. And this one, I didn't even know it existed. So this one is this is made by CST. And there's probably some others on the market. This is a flow simulator. And a lot of the times I use well, let's see what's inside of it. So here's a flow simulator. And it has a dial in here. That's pretty simple. It's just got multiple settings. And it's going to clip onto there. And then it has a chart of information on what number you might want to use to illustrate various flows. So if I wanted to simulate 1500 GPM, I'd set it to setting 9 and give it some information on there. So initially I got this because I use my demo controllers in full test mode. I don't actually run them 9 times out of 10. I'm not running my controller in real world mode, like I'm connected to real wire. I'm going to simulate that I have 200 zones or 5 soil moisture sensors. I really don't have that because I want to keep that contained in my office. Well, so I've realized with this, I can simulate various flows on there. And at first I thought, well, that's great for a very, very, very limited purpose. How might you use this? Actually, there's some reasons you might use this, and they kind of talk about it here and here. One of them is, let's say you're setting up a controller and you want to show what happens when you have a mainline break. We can set this up and not actually have a mainline break. Instead of your mainline's designed to carry 75 GPM, what happens when you run 150 GPM through it? Well, hopefully, you get your alerts and it shuts down the mainline, or it does something, right? It does whatever you told it to do. With this, you could simulate that and actually make that happen without using your flow sensor. thought that was kind of an interesting idea. I didn't know this existed 6 months ago, so I haven't had a chance to play with it, but this is on my list of toys to play with in my lab. Okay, so the other one I wanted to look at is, oh, this is super rudimentary. So, like I said, 9 times out of 10, I am using this fake engineering mode. But there are times when I want to, there was a time when I wanted to see if I could get valves to open on open 1 second and close 1 second. How quickly could I get valves to open and close on a base station 3200? Like, I forget. Maybe it was 1 minute. I wanted to see how quickly I could get valves to open and close. Well, I can't do that in engineering test mode. I want to hear the solenoids click. So super rudimentary. All I did was took a 4-zone bicoder, and now I have 4 solenoids hooked to it. And now I can connect this onto my controller, and I can have a 4-zone system with real devices and get real resistance from real solenoids, right? So I've got 2 of these. I got one with Hunter solenoids, another with Rainbird solenoids. So I could get 8 zones of real devices. Now, if I just used an R board or a powered bicoder, right? So I've got 24 zones here. That's great, but there's no solenoids on this one. So I'm going to get errors when it looks through the resistance in the solenoids. Here I'm not getting errors. It's as if there's an entire real system behind it and it doesn't know. Rudimentary, but it's worth having. Pegboard's great if you're going to be putting weird crap together too. Okay, so the other thing, this is a fun one. So actually that's a little early for that one. So if you aren't aware of them, relays are a wonderful things. So again, if you work with pumps, you know relays, or you know basic relays. If you don't work with pumps, or you don't know that there are relays besides pump relays, there's some really good information. I've got a YouTube video on how to do this one. But so with a relay, all a relay is for the uninitiated is a relay is going to take a high voltage, and this is live. This is actually plugged into my 120 outlet on my office. So I've got 120 coming in, and it's ready to send 120 out, but there's no power on this yet. Okay, and that's because the relay is in the off position. So what it's going to do is take 24 or 30 volts from my bicoder, the low voltage, and then activate the high voltage. And that's really what a pump start relay does, right? That takes a low voltage, and then it's going to run a 220 voltage, perhaps, maybe a 120, maybe a 220, 240. It's going to take a higher voltage and a higher amperage rating and open it in a safe way. It's how you can use low voltage to open high voltage. Okay. So relays are a really fun thing to play around with. This is another one of those things that we have a white paper on this one, and I wanted to hands-on. I just didn't want the white paper. I wanted to play around with it. So I went and got a relay, just like we talked about. This is a Dayton relay and a Dayton socket, and I wired it up and wanted to see exactly how it works. So what I did in one of the videos was someone asked, could I run Christmas lights with a controller? Oh, yeah, you can. And here's how you do it. So in this case, I'm going to plug my Christmas lights in to my bicoder. So I've got Christmas lights plugged into my 110, and it could be hardwired. That goes to my relay, and then this goes out to my power supply. So I've got, let's bring this over just there we go. So I've got power coming in. It's energized right here. So if I touch those screws, I get shocked. It's waiting to turn on. So the relay is in a low voltage switch, and it'll power this. So when my bicoder turns on, let's turn on my bicoder manually here. And when I turn on the bicoder, my Christmas lights turn on. So whenever the clock tells it to, it'll run. So now I have low voltage running my Christmas lights. Now, because I want to demonstrate this really quick, and I'm also lazy, I'm not connecting this up to my controller. I'm just running it on a 9-volt battery. So I have a 9-volt battery operating this switch and that switch is allowing the high voltage through there. So once you start bringing in relays, wow, now that's something that I can really sink my teeth in, is start doing relays, and there's all sorts of things you can run. It's like, well, so maybe you aren't running Christmas lights, maybe you aren't running a pump station. Are you running want to run fans on a patio? Do you want to run, I don't know, what else could we run? We could run fans, we could run, misters, open valves to run misters, or we could, I don't know, that would be really interesting to see. So here's my opportunity where I'm going to ask you. So I'd love to know, drop it in the chat or shoot me an email. Tell me some things that you think that I should test out in my lab, in my home experiment, that you want to see. You want to know, can it be done? Have I not done it? And tell me, I'd love to know some things to do. So I'd also like to know, are there some things that, like, I'm having a little bit of a brain fart. I'm not thinking of some other great things to run with relays, but realistically, once you get to relays, so I could use a relay. I could use a relay, an event bicoder, start, stop, pause conditions. Like, wow, what? Give me some ideas. Give me some things that I could play around with. Basically say, could you make your coffee maker start, Dan, make your coffee maker start when the wind exceeds 5 miles an hour? I don't know why you'd want to do that, but yeah, I'd figure out a way to do that. That's one I haven't played around with. There we go. I just thought of something. I have not played around with event bicoders and anemometers, right? So we could use, I could use a wind switch, right? So there's some other manufacturers that make wind switches that turn off or on at certain wind speeds, or they make freeze switches that turn off or on. And it's just a switch contact. If you want to smarten that up, like I wanted to smarten up this thing, I could connect that to this device and smarten up someone else's hardware, and now put additional conditions with start, stop, and pause, or all the programming. Or it might just be as simple as, I just want to be able to do it remotely with my phone, right? That might be just, I just want to turn on the Christmas lights with my phone. That's all I wanted to do. That might be all you cover. So yeah, so I think wind might be one of the things I want to play around with. One last one to think about. This is really advanced, and I have not been able to have good ideas on this one. So this this pressure transducer, right? So this runs on this way. This sends its signal to the bicoder is it sends between 4 and 20 milliamps. So this is what the industry calls a 4 to 20 milliamp device. And it's a rather simple way of sending a sensor signal, and it's almost like, I think it's an analog signal that we translate into digital. And a lot of temperature and pressure things are use 4 to 20. I thought, well, what else could I use that's 4 to 20 milliamps? Because this bicoder right here recognizes 4 to 20 milliamps. So could I take someone's temperature sensor and connect it to it? Could I take Chris Wright's asked me about, could I take a scale? Could I take a weighing scale that reads 4 to 20 milliamps and run it to that bicoder, which was intended to pressure, and use it to do something, to automate a process? Yeah, I can. I just need to put my hands on that scale. I need to find it. So that's the part, right? Is think of something creative, drop me a note, or shoot us a message to the website and challenge me and tell me something that I haven't done that you want to see. And I'd love to play around with it, because it's really good learning for me. It's good learning for everybody else, and it's fun for me. So I really enjoy that. So, well, look at that. We ran out of time, so we're on our time today. So I want to thank you for joining in my laboratory and kind of looking at some of the weird things that I build and make. Sometimes, just to entertain me and amuse myself, but really to learn and to do better for you, so I can answer those in-depth questions, or to challenge you like I'm challenging you now. Tell me something that you want me to test out, and I'll figure out how to do it. I got a company credit card, and they want me to learn stuff. So between those two, it's a good match for us. So, well, thank you all. Thanks for joining us. next time, Chris and Andy are on, and hope you can catch them then. Have a great week, everybody. Take care.